We've been doing that, so it's not something that is part of InHeart products, but I can comment on that because we're doing research on that. So InHeart does 3D modeling, and we can use these 3D models to assist stereotactic radiation therapy. But for that, you need a specific software in order to trace the targets, register electroanatomical maps and everything. And this is not yet part of InHeart products, but maybe I can show what we're doing in that prospect. So it all starts with the InHeart models. So for instance, this patient was a patient from Toulouse, from our good friend Philippe Maury. He had this very large anterior infarct that is mapped using wall thickness. And Philippe could not enter his LV to ablate his VT because there was this very large clot on the LV apex. So what he did is an epicardial procedure using the high density mapping. So it was a arrhythmia system. During sinus rhythm, he could not map the VT. So what this mapping showed was an anterior channel here that was also visible on this thickness map. We will get that later. And then based on these two informations, he traced a target on the volume. And then we can export this target along with structures at risk that may be damaged during ablation in the format that is suitable for SBRT planning systems. So it's called the RT-struct format. So we've been doing that in about 50 cases in multiple sites. In fact, the Brigham is the most active sites. They've been doing 10 to 15 cases with our technology. And it's very variable. Of course, for now, it's a last resort technique that is used in the context of compassionate use. So sometimes we only have imaging, very rarely, but sometimes we only have imaging because the patient has two mechanical valves. It's impossible to access the LV. Sometimes, and most of the time, we have prior EP maps because the patient has undergone multiple failed ablation, and we can use that to refine the target. And yeah, so it's doable. It's not yet a product delivered by InHeart, but it's leveraging on obviously the capacities of InHeart to map the anatomy, the substrate, and to transfer that in the EP world. InHeart produces the 3D model, and we are developing academic software that allows us to fuse the InHeart models with EP maps to draw on these models targets and to export these 3D targets as RT-struct files that are readable by platforms. But then the fusion with the 4D planning CT of used by to simulate the dose and to expand to address the motion during breathing and all that is done on other systems, proprietary systems that are already used for treating mobile targets with radiation therapy, such as lung nodules. But yes, we can use the InHeart solution to refine the target.